Hey math fans, we're on section 5.5.2. Let's get started. For the past few sections, we've been talking about rigid motions, which we also call congruency transformations, which means that the before and the after picture, the pre-image and the image, are congruent. However, this section is going to be more about the non-rigid motions. They're also known as dilations, stretches, and compressions. The main way we're going to decide whether or not a dilation, or if something is just vertically stretched or compressed or horizontally stretched and compressed, is going to be measuring the side lengths. If the side lengths remain the same, then obviously a rigid transformation, pre-image and the image will be congruent. But a dilation is when actually the horizontal and the vertical get stretched to the same scale factor or compressed to the same scale factor. Here's some pictures of a dilation versus vertical and then horizontal transformations. Again, a dilation, everything will be compressed or stretched, or they call it enlargement or reduction. The vertical and the horizontal will be getting bigger or smaller at the same rate. It'll have the same, what is called a scale factor. A vertical transformation is just going to get stretched vertically or compressed vertically. A horizontal is just going to get stretched or compressed horizontally, and nothing will happen to the vertical component. Here are some common errors and misconceptions. Example 1, determine if the two figures below are congruent by identifying the transformations that have taken place. I'm going to want to see, when you guys are doing these examples and when you're doing the practice, I'm going to want to see proof that the pre-image is congruent to the image. You're going to do this by determining the lengths of the sides. So in the picture, AC was equal to 3 and A prime C prime is equal to 3. The distance from C to B is equal to 5. And the distance from C prime to B prime is equal to 5. The third side, though, is on a diagonal. It's not going to be, I can't just count the number of units. I'm going to have to use what's called Pythagorean theorem. Pythagorean theorem is A squared plus B squared is equal to C squared, or in other words, the leg squared plus the other leg squared equals the hypotenuse. And remember that AB is your hypotenuse, and A prime B prime is your hypotenuse. So we're going to end up getting the square root of 34 for the distance from A to B and the distance from A prime to B prime. Did the measures change? The answer is no. So I know a rigid transformation has taken place, but which one? So we have to take a look at the pre-image versus the image. And it looks like that it's definitely been flipped, but it's also been translated. And I can see that it's been translated to the right 4 units. So it's actually a composition of transformations, composition of rigid transformations. Example 2 has triangle ABC and then triangle A prime, B prime, C prime, and we're going to determine whether the figures are congruent. Some of you guys right off the bat will say, no, they are not congruent. But we're going to have to go a step further. I want the actual distances from A to C and then A prime to C prime, because we're going to see if we can develop a scale factor out of this. So the distance from A to B is 3, and the distance from A prime to B prime is 6. Obviously not congruent. So this is going to be a non-rigid transformation. The distance from A to C is 4, and the distance from A prime to C prime is 8. Once again, we're going to have to use that Pythagorean theorem. 3 squared plus 4 squared is going to be equal to that hypotenuse squared. Also, 6 squared plus 8 squared is going to be equal to the other hypotenuse squared. So we get CB is equal to 5, and C prime B prime is equal to 10. Now, ask yourself this: do you see a relationship between the pre-image and the image? You probably recognize that it was a factor of 2 that these distances were being multiplied by. How do you get that factor of 2? Well, mathematically, we're going to be dividing the image length divided by the pre-image length. As you can see, I have 6 divided by 3, 8 divided by 4, 10 divided by 5. All a factor of 2. We call that a scale factor. And if all of those measurements are the same, then we can call it a dilation. So my conclusion is this triangle has undergone at least one non-rigid motion, a dilation, and it's an enlargement with a scale factor of 2. The enlargement means that the pre-image was enlarged to create the image. Example 3, determine if the figures below are congruent by identifying the transformations that have taken place. Again, we're going to go through and do each side length, AB, BC, CD, DA. As you can see, I have all the distances for all of my segments in the pre-image and the image. And then we got to see if we can come up with the scale factor and if that number is all the same. But as you can see, this is going to be another non-rigid transformation. Maybe you notice that only the vertical lengths have changed. So this will not be a dilation. How much of these lengths increased or decreased by? Well, they've actually decreased by a factor of 0.75. So we would say that there has been a vertical compression with a scale factor of 0.75, or in other words, the pre-image became 3/4 smaller, or multiplied by a factor of 0.75 to create the image. We call that vertical compression. The image has become smaller than the pre-image. Example 4, determine if the figures below are congruent by identifying the transformations. Again, analyze all the line segments. You got to show all this work here. And as you can see, the numbers are all the same, aren't they, for the pre-image and the image? So what has happened here? Well, we can see that it's in a different orientation. The figure has actually been rotated, which is a rigid motion. Therefore, the 2 figures are congruent. And that's going to do it for this section. We'll see you in class.